In this video, we will study composition function and the inverse of bijective function. Consider A as a set of all students who appear in the class 10th examination of CBSE board. Each student appearing in the board examination is assigned a roll number by the board, which is written by the student in the answer script. In order to have confidentiality, board removes that roll number from the answer script and assign a fake code number to each roll number. Let B be the set of all roll numbers and C be the set of all code numbers. This gives rise to two functions, f from A to B and g from B to C. Thus, by combining these two functions, namely f and g, each student is eventually attached to a code. This leads to the following definition. Let f from A to B and g from B to C be two functions. Then the composition of f and g denoted by GOF is defined as the function GOF from A to C given by GOF of x is equal to g of fx for every x belongs to A. Let us also define an invertible function. A function f from x to y is defined to be invertible if there exists a function g from y to x such that GOF is equal to ix. Here ix means identity function in x, and FOG is equal to iy. Here iy means identity function in y. The function g is called the inverse of f and is denoted by f inverse. Thus, if f is invertible, then f must be 1, 1 and onto, and conversely, if f is 1, 1 and onto, then f must be invertible. We will use this fact to prove that a function is invertible, especially when the inverse of a function is very difficult to be determined. Let us solve some questions from the exercise. The first question is, let f be a function from the set 1, 3, 4 to the set 1, 3, 5, and g is a function from the set 1 to 5 to a set 1, 3 be given by f is equal to 1, 2, 3, 5, 4, 1, and g is equal to 1, 3, 2, 3, 5, 1. Write down GOF. To solve this question, for writing down GOF, we have written both the function f and g in the mapping form. Now under f, 1 maps to 2, 3 maps to 5, and 4 maps to 1. Under G, 1 maps to 3, 2 maps to 3, 5 maps to 1. If you start with 1, you will reach at 2 in the first stage, then you will reach at 3. So GOF will be 1, 3, first element. Second, we'll start with 3. Intermediately, we'll reach to 5. Then the final destination will be 1. So second element will be 3 is to 1. Then if you start with 4, you will reach at 1. Then finally you will reach at 3. So third element will be 4, 3. So this is the GOF function. GOF is equal to 1, 3, 3, 1 and 4, 3. Let us discuss the next question. The question is, state with region where the following function have inverse. First part is function f from 1, 2, 3, 4 to 10 with f is equal to 110, 210, 310, 410. Clearly this function is many one. See, 110, 210, 310, 410, 1, 2, 3 and 4 all have the same image at 10. Hence this is many one function. First and foremost condition for a function to have inverse is the function should be bijective function. That is, it should be 1, 1 and onto. This function is not 1, 1, hence it will not have any inverse. Second case, g is a function from 5, 6, 7, 8 to 1, 2, 3, 4 with g equal to 5, 4, 6, 3, 7, 4, 8, 2. This function is also many one. See, two element of the domain 5 and 7 has the same image at 4. So this also is not 1 1. So this function will not have an inverse. Now let us discuss the third one. H is a function from 2, 3, 4, 5 to 7, 8, 11, 13 with h equal to 2, 7, 3, 9, 4, 7, 5, 13. See, no second element is repeating here. 7, 9, 11 and 13. This means that the function is 1, 1. And 7, 9, 11, 13. 7, 9, 11, 13. No element is left behind in the codomain. It means that in the last case, h is 1, 1 and on 2. Hence, it will have an inverse. We can write the inverse of this. H inverse is equal to 2, 7 will be 7, 2. 3, 9 will be 9, 3. 4, 11 will be 11, 4. 5, 13 will be 13, 5. So only the third one will have inverse because first two functions are many one. Hence, they are not invertible. Let us solve one more question. The question is, consider f is a function from R to R given by fx is equal to 4x plus 3 so that f is invertible. Find the inverse of f. Consider an arbitrary element y belonging to R. This R is codomain such that y is equal to 4x plus 3 for some x belonging to the domain. This R is for the domain because here domain and range both are same. So we have to distinguish like this. This implies 4x is equal to y minus 3 or x is equal to y minus 3 by 4. Now let's define G from R to R. This R is codomain and this R is domain given by Gy is equal to y minus 3 by 4. Now GOF of x is equal to G of fx is equal to G of fx is as per definition 4x plus 3. 4x plus 3 is equal to G. G is defined as Gy is equal to y minus 3 by 4. So in place of y, we'll write 4x minus. In place of y, we'll write 4x plus 3. 4x plus 3 minus 3 of the definition divided by 4. Now this 3 will cancel this. You will have 4x divided by 4. Finally, we will have 4x upon 4 is equal to x. Now let us find FOG of y, that is f of gy. Now what is the definition of g? G is y minus 3 upon 4. Y minus 3 upon 4 is equal to, what is the definition of x? It is 4x plus 3. Fx is equal to 4x plus 3. So in place of x, we'll write y minus 3 by 4 in the definition of the function fx. Y minus 3 upon 4 times plus 3. This 4 will cancel this 4. We'll get y minus 3 plus 3. Finally, we'll get y. Starting with y, we are getting y. Starting with x, we are getting x. It means that in both the case, we are getting identity functions. It means that f is the inverse of g and g is the inverse of f. And hence, f inverse is equal to, now what is the definition of g? G is y minus 3 by 4. So x minus 3 by 4 will be the inverse of f. This much only in this video. In the next video, we will solve some more problems on composition function. Thank you.